So let's go to a quick little summary at the beginning of the lesson. So the theme for this week is exploring the relationships between circles and tangents. And the three relationships, or the three theorems that we have learned about, what I'm going to try and draw for you now. Let's see how good I am at this. Let's have another tangent. Okay, so I should also have this. The three theorems, or the three facts that we've explored, are the tan radius theorem, which says that if you've got a tangent and you've got a radius, they will always be perpendicular to each other. And I'll show you in a moment. Then we also said if there are tangents from a common point, tangents from a common point will always be equal in length, and they will form an isosceles triangle between those 2 points. So that is the other thing, and we call that tangents from a common point. And then in the last lesson, we spoke about what's called the tan chord theorem. And what that says is if you've got a tangent and you've got a chord, you'll always have an angle between them. So let's make it the green dot over here. If you then take the chord that is participating, it will subtend or make an angle at the circumference. Then those two angles will be equal to each other. You can also see this if you go from the other side, where you imagine a tangent and a chord, and then the angle will be, say, that one over there. If you use that chord as the base, you then can subtend an angle at the circumference on the other side, and those will be equal to each other. So I know for those who it's your first lesson, you must be like, whoa, that's a lot all at once. But these are the basic ideas that we'll be using throughout today. And so let's just have a quick visual recap of these ideas. So I've got some nice animations to just show you these ideas in practice, that they are actually true. So this is the tan chord theorem because it's got the tangent and the chord with a relationship. And sometimes we call this the windsurfer theorem. And the reason we call it the windsurfer theorem is it looks a bit like a windsurfer. Now, as we start here, you'll see that the pairs of angles are equal to each other. And what I'm going to do is I'm going to start moving around things that I can move around. Now, what you'll notice is that even though the angles change, the relationships between the two, the angle between the tangent and the chord and the angle on the alternate segment, they stay the same. And so this is the theorem that I was trying to show you up here. So that will be in play today. Then the other thing that will be in play will be this one, which says that you can see if I move the tangent around the circle, it always stays at 90 degrees. The tangent and the radius's relationship is perpendicular. And then the last one, it always looks to me like two hands holding a ball or something. And I'll just show you, like, you can move this point wherever you like, and the length will change, but the actual relationship will always stay that they're equal. So you can see how you can move that closer and further away, and it stays the same. Can we have a quick little vote? Thumbs up if you understand the basic ideas that I've put in play there. Thumbs down if you feel a bit overwhelmed with the detail. I'm hoping that recap just solidifies what we spoke about in the last lesson. Okay, that's good. Let us go to a quick little, I think we did this one in the last lesson already, so we have done this one. So let's go to this one, which is a bit more interesting. Okay, So the sketch shows EB as the diameter. So EB is the diameter. And ABC is a tangent of the circle. So there is ABC. If DBC is 72, so if DBC is 72, where is DBC? DBC. If DBC is 72, then D plus EBD equal what? So here's D, and EBD is going to be this one here. So they want to know, if I give you the stuff in red, what is D plus EBD? And I want everyone to have a look and then vote for the answer that they think is true. So take a moment to think about the relationships we've discussed, and then you can tell me what you think your answer is. Look for the shapes that I was mentioning at the beginning. And also remember that this was called the diameter. And if it's a diameter, it must actually go through the center of the circle. So the moment they tell you it's a diameter, it must go through the center of the circle. I see a couple of answers coming through. And would anybody be willing to share how they got there or the thinking that they followed? Doesn't have to be long, but I just want to get a sense of what you went through. Letty, let's go to you.
Hi, sir.
Hey.
So what I did was I saw that the diameter is in the middle, so which means ABE is 90 degrees.
Oh, so
Therefore,
this must be 90 over here. Yep. That's the tan radius theorem. Yeah.
a straight line, which means angle B is 18 degrees.
Okay, so which means this angle in between is going to be 18. Okay, fantastic. And then?
And then D is 90 degrees because of the triangle you showed us, that 90 degrees.
Yeah.
Can go there. Okay. Yeah.
Perfect. So you're right. So earlier in the series, I spoke about how the diameter will always subtend an angle at the circumference, which is 90. So you could have got it like that. The other way you could have got it, so that's perfectly correct, probably the easiest way to do it. But you can also use the tan chord theorem. So watch this. This is a tangent. And this over here is a chord. Now, you know that this angle over here is 90. But now the angle that it builds over here at the circumference will be the same as what that is. And so you can also say that D was 90 by using the tan chord theorem. That would be equally as good. Now we had the 18, we had the 90, so together that gives us 108, and the correct answer is B. So there was actually more than one way to do that. Quick vote, thumbs up if you feel okay with that, thumbs down if you don't. I'll show you what I mean about the 90 thing here. So if you imagine that this is a tangent and this is the chord, that relationship is the one that you build on. And now I'm going to build the angle up here, and that one is going to be the same as whatever this was. And this was 90, so therefore this must be 90 as well. And then earlier in the question, we said that that was 18. Okay. I'll come back to this one later, but I think that we'll get better as we go today. So in fact, well, let me leave it up on the board. Let me see if I can't shrink this. And so while others are busy with this new one, let me leave it up on the board. I'll have another go at explaining the one above here. Oh, goodness. I'm trying to do too much here. Okay, so I want everyone to try and do question 7 that is currently on the board. You have to vote for your answer. And then I will try and see if I can't have a go at this other one over here. Oh, goodness gracious. Okay. Let's see if I can. So I don't know if you can see Tantaki there, but really DBC. So this was 72 to start with. And we know from the tan radius theorem that this thing over here must be 90, which means that has to be 18. So tell me in the chat, Tandakile, if that makes sense to you. Okay, then from that point, Tandakile, if you think about the like basically using the tan chord theorem on this bit here. Here's the tangent, here's the chord. So you know whatever angle is made between the tangent and the chord must be equal to the angle formed over here. So basically this one over here is going to be equal to this whole one over here. And so because that is 90, because that's 90, that also has to be 90, essentially. Okay, I'll come back to it at the end of the lesson, but for now I'm going to go on with question 7. Let's have a look at this one. This is a diameter, so that means there must be a center point in there. A lot of students are saying C. Who would like to tell me the answer to C? Who's willing to share their thinking? It says that R is 36. So I think that could be helpful to start with. If we say that that is 36 degrees. Fatejo, let's go to you. What did you think?
Okay, so I figured that there would be a 90 degrees since it's on the diameter, right?
Yes.
So I'm just going to say 180 minus 36 minus 90, which is 54.
Okay. Yeah, so this theorem that we did actually in earlier lessons, where if you have the diameter always subtends an angle at the circumference, which is 90. And so that's going to be 90. So give me the next, then you went to where, Fatejo? You went after the 90. I'll ask you to unmute. I'll just come back to you now.
After that, I said 180 minus 36 minus 90.
Okay. And so then what did you get?
54.
So did you get 54 for this thing up here?
Yes, sir.
Okay. So we're still trying to get to T, which is over here. What was your next step after that?
So I don't know what I did.
Okay, no problem. I like just taking you through the thinking, so I appreciate that. I'll take it from here, but that was awesome. So what I think needs to happen is that this angle over here is equal to 36. Okay, so that angle over there is equal to 36 because of the tan chord theorem. And then on this side, let's see if I can zoom. If that's 54, then I know on the other side, it must just be 180 minus 54, which is going to be, let's have a look. 180 minus 54 is 126. And again, there could be other ways to do it, but I was thinking then T should just be 180 minus 126 minus 36. And what do we get for that? I think we get 162, which leaves us with 18 degrees. So this was quite a bit harder, but that's because we're building on these questions. So let's just go through that from the top. In the beginning, it said, what is t equal to? Now, the very first stop on the journey was to say that if r is 36, that's good news for us. We know that that's 36. So let's even write that in. Then we said that this angle S or RSU is equal to 90 because of another theorem. Then we said that this angle over here is going to be 36 because of the tan chord theorem. Then we worked out with the sum of angles in a triangle that this was 54. And at that point, some of you might have been able to use another way, but I'm using the way that I think makes the most sense. Then I said angles on a straight line gives me 126. And then in order to get the very last thing, which is this t in the corner, I just went 180 minus 126 minus 36. And that's how I know that this is 18 degrees, which would be the answer would be A. Now that's a bit of a toughie, but again, that's part of the standard class is raising the level as we get to the end of a course. Give me a thumbs up if you followed my argument. Give me a thumbs down if you feel a bit like not so happy. Okay, now there's a mixture, which is fine. So what I would suggest you do is you come back and watch just this section of the video. But there are some questions here that I want to try and answer. So Cass and Londi have asked a couple of questions. So I want to first of all say, how did I get this S that's 90 over here? Now, at the beginning in lesson 2, I think it was, we spoke about a theorem which said, if you have a diameter, so if you have a diameter, a line, a chord that goes through the center of the circle, if you subtend an angle at the circumference where you use that diameter as the base, this angle will always be 90. So it doesn't matter where those, if you've got a diameter and it goes through the middle, wherever that angle is, as long as it's subtended by the diameter, it will be 90. So that's where that comes from. Then how did I get 36? Well, in the question, it said R was 36. And then I said, well, I'm going to use the tan chord theorem, which we were practicing earlier on, which says here's a tangent, here's the chord, and here's the angle in the alternate segment that I make by using the chord as the base. So that's how I knew that these two were 36. And then if I know two angles in a triangle, I can get the 54. So that's how I got the 54. And then angles on a straight line add up to 180. And so that's how I got the 126, or angles on a straight line. Okay. Again, you don't have to be perfectly comfortable. You can always come back and watch this again. But I think we've given it our brains enough of a kind of thing to think about to help us learn. So let's do one more question before our halftime break. Have I done this question with you yet? I'm forgetting if I did it in the previous lesson or not. Okay, so then let's do it. I want you to find for me X, Y, and Z. Okay, that's good news. I haven't given it to you, and it's a lovely question. So over to you guys. And I want you to think about the 3 main facts or theorems that we're using today. So I'm going to suggest that this is 90 because of the tan radius theorem. And I'll even use the more formal layout. So BTO is 90 degrees, and that is tan radius theorem. And then X would be equal to 180 minus 36 minus 90. And that should be 54 degrees. And the formal reason would be to say the sum of angles in triangle. So we know that this one over here is 54. Now we need to find what Y and Z are. So Tandikile and Siposetu, Refense have all put answers in. Keep them coming. Letty's got an answer there too. There's two ways you could get the answer for Y, but both of them will be 90 degrees. I'm guessing that probably the easiest, what most of you used was the tan chord theorem, but you also could have written angle in semicircle, which is from the earlier video that we did. Both will be correct. And then the last one would be Z. So Lolo, if you look at this shape, so if you follow this tangent and then this chord, the angle between the tangent and the chord is 90 degrees. But the tan chord theorem says that this angle has a partner, and this partner is found by taking the chord and making an angle at the circumference on the other side. And so this one over here is the same as this one over here. And so that's why Y must be 90. However, you could also use the reason angle in a semicircle. So angle in semicircle. Now that reason for Y is 90 would just say, look, I know that this is the diameter. And since this is the diameter, any angle made by the diameter at the circumference will be 90. So this is a case where if you mark matric exams, there's always multiple ways to do it. And both of those reasons would be acceptable. And then the last one is Z. Well, Z will be, it's just going to be 180 minus 90 minus 30, which is 60. And the formal reason would be sum of angles in triangle. Now, I'll get you right now for Tejo. What you notice is for the first time, I'm writing in the formal reasons. Now, the way I teach my classes this section is I very much focus on the visual understanding first, because it's like trying to run your engine. If you try and do both at the same time, it's a bit much. But as you get more comfortable with this topic, what you'll notice is whenever you make a statement, you normally have to make some sort of backup statement or a reason or a theorem that supports why you know what you know. And so I'm going to start to work that in little bit by little bit. But if you're feeling confused, I want you to just ignore the reasons. Okay, it's only once you've mastered the visual that you can worry about the reasons. Let's go to Fatejo. What's your question?
Okay, so I can see that the two reasons for Y being 90 is the tan chord theorem and angle in semicircle. So what if you use the reason for the fact that there's a diameter which subtends so there has to be a 90 degrees.
Angle, diameter subtends. Okay, yeah. So there are some variations, and so what I would suggest is that you follow the reason that your teacher at school says, but in reality, when you mark matric papers, there are a list of acceptable reasons. And so I suspect the one you're describing is one of the variations. I'll try and talk a little bit about reasons at the end of today. But the reality is there's a couple of acceptable ways to say it. The main idea is we want to know that you understand where your fact came from. Okay, does that make, yeah.
My second question, may you please explain the reason for angle in semicircle?
Angle in a semicircle. So
Yes.
how about, let me just go to my theorem drawing here. So if you look at so this should actually be angle in semi, it's not angles, but it's just the fact that you have a circle, and whenever you have a diameter, whenever you subtend an angle at the circumference, that angle will be 90. So that's what I'm basically needing to know. I'm not covering proofs in this particular topic. There is a proof for this. The proof comes from another theorem. But for now, I'm just going to leave it at, it is true that if you have a diameter, so it has to go through the middle, and it subtends an angle, it will always, it should always be 90, but it has to be a diameter. At the moment, it's not a diameter. In fact, let me show you, going back to lesson 2. Let me zoom in here. And let's have a quick look back in the past here. So if you want to watch the recording of lesson 2, it obviously is available, but have a look here at how, if you move it around, the angle from the diameter stays the same. So you can see it visually. The moment you have a diameter, if you move this off the diameter, right? Notice how the angle changes to 98. If you move this back on, it's 90. Now, I would really recommend I'm going back to watch video 2 to get a better understanding of that one. Okay, what I think we need now is a brain break. So I want everyone to stand up. We have been going hard for a while now, and our bodies need to get a bit of unwinding. And what I want to ask you to do is to stand up and shake yourself loose. And we are going to, we just turn from one side. And when you first start, you're not going to turn too much. And then as your body relaxes, I want you to let yourself turn a bit more. And everyone's flexible in different ways, but you should find as you relax, your body lets you turn further. And it'll be a sign that you're unwinding and you're relaxing. If you feel your body unwinding, you should be able to go further. Okay, then what I want you to do is I want you to have your arms up horizontally, and I want you to start with small circles going around like this. So little circles, you should feel a little bit of pressure on your shoulders, and then you make bigger ones and bigger ones until you're making the biggest circles that you can. And that's it. Okay, then what I want you to do is I want you to roll your shoulders a little bit. So roll your shoulders back. So roll them back. And then roll them forward. Yep, Kat, unfortunately things do click. I'm told by medical people it's just the air moving around in your body. So we should all be fine. Then let's do a little neck stretch. So to the left, 1, 2, 3, 4, 5, and to the other side. I'm hearing lots of clicking in my neck. 1, 2, 3, 4, 5. Okay, now we need to get our heart rate up. We're going to do something different this time. We're going to do knee taps. And so what you're going to do is you're just going to do that. So 1, but you're going to jump 2, 3, and so on. Okay, we'll do maybe 16 of them. So we'll get started and let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. And that should have got your heart rate up. If it didn't, go to 20. But I think your body should be feeling a little bit less mathematical after that. And a little bit more human or whatever. Yeah. And here is your puzzle for today. Can you solve this maths puzzle? Over to the students. The main idea with this one is you need to make sure you consider something called BODMAS. And what BODMAS says is that that gets priority. And then while people are, I can see quite a few students have got an answer for question 1. Here is a second puzzle for today.
Recording in progress.
Okay. For the first one, my first step would be 7 minus 1 plus 49 minus 7, which then gives us 6 plus 49 minus 7, which gives us 48 as the final answer. What about the pink one? What do you guys get for that? You should really be doing this without a calculator. Then I suppose it's less, or it's more tricky. Let's see.
Yeah, no cheating, guys.
Those answers are coming in awfully fast.
We should have put a disclaimer at the beginning there.
Yeah, I should have said no calculators are allowed. So for the second one, I just use like basically that top and times technique, right? So if you got 3 divided by a third, it's the same as saying 3 times 3 over 1. And then that means I end up with this minus 9 here. And that basically means that 9 minus 9 is 0. And the final answer is 2, which is what I saw popping up in the chat just very, very fast.
Well done,
Hence my
guys.
skepticism.
Well, Repensa says no, they're smart. They were not cheating. They're just smart.
Okay. Yeah. All good, all good. Okay, so today I just wanted to check that everybody understands BODMAS quite well, and I think you've shown that you understand that. So let us return to the second part of today's lesson. So I'm going to choose some variations. Let us do number 6. So I want you to do number 6, and I want you to do number 8. And let's start with that one. Let's make that nice and big. And over to you. I want you to find for me the value of m, the value of n in that one. And then in this one, you have to find the value of a and find the value of b. Who would like to share how they did number 6? I'm interested to hear some student thinking in terms of the process they followed. Kat, let's go to you. Hi, Kat.
As I use the rule that the two arms are going to be the same length.
Okay, so tangents from a common point. So you basically said this is an isosceles triangle.
Yes.
And which did you find first?
M.
N, and what did you get for N?
M, sir.
Oh, M.
Mm.
Okay, how did you get M? By the way, like, I'm just wondering, teach me how you got to M.
Since this is an isosceles triangle, I just said 40 plus 32,
Yes.
and then that angle is going to be equal to the other angle.
Okay, so am I describing it right on the screen? That basically this one and this one are the same, they're both 72.
Yes.
So then N would be 180 minus 72 minus 72. And what did you get then for N?
I've got a negative angle.
Okay, you shouldn't get, because you go 180 minus 72 minus 72. So
And it was 36.
36, yes. So I get that this is 36 over here. Now I'm wondering, how do I get M? This is a bit trickier. Visually, you have to, like, yeah. Would anybody be willing to share their thinking for M? Letty, let's go to you.
So what I did was that the two angles next to M are equal, so they're both 40 degrees.
You think that this one and this one are 40?
Yes.
Okay, I feel drawn to it, but the problem is the only isosceles triangle that I know about is when we have radii, and normally you have to have the center of the circle and then it kind of goes out. I feel tempted by your 40, but it doesn't feel quite right.
Okay, so we can also say 36 times 2.
36 times 2 for which one? For M?
Yes.
Aha. I love your thinking, because you're thinking of the arrowhead. But the problem with that one is you need to have, but I love these suggestions. There's a theorem that we did in the second lesson, which says that this angle over here is twice the size of the angle here. But you have to have a circle going through it. And the problem is there's no circle going through the outside part. I'll give you a little tip. Can you see this angle over here? What angle would be equal to that one over there? Was my thinking. That little blue dot over there. This is a nice question. It really requires, see if you can figure out what that one is. We do know that the whole of this angle is 72 from earlier on, right? So we know that whole angle is 72, but what I'm very interested in is, can we figure out what that blue dot is there in the corner? Would anybody like to come and explain how they got that blue dot? I was thinking, follow me on this. Here is a tangent, right? So here's a tangent, here's a chord. So here's a tangent, here's a chord. Now, if I had to go into the circle itself, isn't this one over here an angle that's subtended at the circumference? So I was thinking that this one over here should be 40. Now that's tricky because it's coming from the top to the bottom, but it looks correct to me. Now, if we know that's 40, I would love to know in the chat, what is this angle over here going to be? What's the green dot? Now we've got some information that we've used already that I've rubbed out. What is the M going to be? Okay, so it looks to me like everyone has realized, oh, wait a minute, this angle over here is the same as this one here. If that's 40, then M must be 32. Or not M, sorry, M, I mean the green dot. So this must be 32. Now, the final thing, what is M going to be equal to? So it looks to me like M, yeah, Mosima, let's go to you. Mosima.
Hi, sir.
Hey.
Sir, I'm thinking M is going to be equal to 180 minus 40 minus 32.
I completely agree. So were you were using this and this, eh?
Yes, sir.
And what was your final answer?
My final answer was 100. Let me see, 108.
Yep, perfect. 108.
Yes.
Now, let's finish off today on a well, yeah, I'm going to show you a few things at the end of the lesson, so I'm going to leave some more time, but let's try and find A and B now before we get to that part of the lesson. But number 6 was a toughie. Sure, that was a really forced us to think deeply about it. Explain how it is 36. So Ayabonga, if you look at the original question, we had this, let me use the green. So if you look down here, they told us that this green bit here is 40 and 32, which together is 72. Now, because of the red tangents from a common point, we know the two tangents are equal in length, which means that this angle over here will be the same as that one over there. But now you've got two lots of 72, and the only remaining thing in the triangle is the n down here. So how do you find it? You simply go, n is 180 minus 72 minus 72. That was my thinking. Okay, so on this one, I think most students would have said, here is the tan chord. And then by the same thinking, this one over here must be 74. But there are these two little markers, and what they're telling you is that this is an isosceles triangle. And because it's isosceles, the angles opposite the equal sides must be equal. And so then A would be 74 degrees. So this one over here is opposite that side, and it's 74, which means the one opposite this side must also be 74. What is B going to be? So B looks to me like it's just going to be 180 minus those two angles. So 180 minus 74 minus 74, which is going to give us what 32. So this should be 32. Fantastic. Okay, so what I'm going to do in these last sort of 5 minutes before we give you the link to the quiz is I want to zoom out and just give you an overview of the section. Now, we have given you 6 lessons to really get your visual understanding of circle geometry up to a good level, or at least at a decent level to begin kind of achieving high marks. But there is quite a lot in the section. And so I just want to kind of take you through an overview of the stuff that we've done, and then what other things your teacher will probably do with you in class. So let's just take a moment to do that. And if you want to take pictures or screenshots or whatever it is, you can do that. So the stuff that we've done this week really focused on the relationship between about tangents and circles. So tangents and circles. And so that's what this week's quiz is going to be about. And so the official reasons that when we use these arguments later on is, well, actually we can use tan radius, then tan chord, and then tangents from a common point. So those are the three theorems that you have a visual understanding, but you do still need to work to get to sort of test level understanding. So take a picture here if you have to. And then I'm going to talk about the other stuff we did. Okay, 3, 2, 1. Then in the middle week, we spoke about what's called cyclic quads. And cyclic quads are where you have a circle and you have a quadrilateral where all 4 points are on the circumference of that circle. And so the three theorems that we dealt with were angles in the same segment, opposite angles of a cyclic quad, and exterior angle of a cyclic quad. And so we covered a lot of visual questions around that. But this is really the grouping of cyclic quads and circles. So take a screenshot if you want for that. So 3, 2, 1. And then when it came to the first topic that we did, and we didn't do all of these theorems, but I'm going to show them to you because you will encounter them. We spoke about theorems that deal with a circle and its center point. Now, the one that we spoke about today a little bit was angles in a semicircle, which is this one here. And that was the one where if you have a diameter, it always makes an angle of 90. The other one that I spent a long time on, and it's also probably the most important one, is that the angle at the center is twice the angle at the circumference. And so those were the two ones that we focused on because they are the ones that mostly, come up. But there are these theorems which also are involved. And if we do exam prep around this or another unit on circle geometry, I will come back to them. But in my brain, when I think of circle geometry, I think of circles in the center, circles and cyclic quads, and circles and tangents. And then that's how I begin to store my learning. Can you give me a thumbs up if this is making sense? Thumbs down if you are feeling lost or overwhelmed. Just want to get a feel for what the class is making sense of this. Okay. Now, the other thing that you will also encounter in class is they will talk about something called proofs. There are certain proofs that these are claims of facts, but sometimes you have to prove them. And so again, if there's more time, we will come back to them and do that too. But this one in particular is a particularly popular proof that you can learn. It's not hard to learn, but you need to put the hard work in. And there's also then something called converses. And converses deal with how do I prove something is a tangent? So how to prove the following things. A tangent, or how do I prove that something is a cyclic quad? Or how do I prove something is, etc. So the two sections or two topics that we haven't really spent too much time on are proofs and converses. But that's because if you're given limited time, you really should focus on the stuff that is going to make the biggest difference. And from my experience, having a good visual understanding is a fantastic base. It gets you lots of marks. And then from there, you can go up to the higher levels of achievement. Okay, so I hope that gives you a feel for what we've done and what we still need to do. But from next week, we're going to be moving on to trig. And then, Lebo, if I could ask you to put a link to the quiz for this week so that students can have access to that. And then, are there any final questions or comments anyone would like to make on this topic? All right. So I'm not seeing too much coming through. So then I would suggest please do the quiz by tomorrow latest. And yeah, thank you so much for coming on this journey. Mpo, it is a bit of a tough topic, but my experience is if you understand these 6 lessons well, right? So you don't worry about the other stuff. You just get your 6 lessons done well. Once you feel comfortable with this, you're able to move on to the other stuff and it gets easier, but you can't rush. It's like changing gears. If you change gears too quick, your car will stall. It won't go anywhere. And so I think I really want to encourage you to practice this stuff before moving on. Yeah. I wonder if anybody else found that. So someone who's done the 6 lessons all together, did you find that it got easier as you kept coming back to it? I know that people do find it tough. And I'm hopeful that I will be able to do another unit on this topic where I come and almost build off these 6 lessons and we can go to the next level. Yeah. My experience is I see lots of students get rushed with this topic. And if you get rushed, they really get disheartened. Don't worry. For those who it's their first lesson, I totally expect that today might have been a bit tough. I really don't want you to be discouraged. Anybody would have found that tough if it was their first lesson. So the main thing is if it was your first lesson today, look at the process we used, and also look at the previous video, look at the very first video in the series and ask yourself after watching that, how did that feel? That's what I would encourage you.